To the Honor Committee, we are students from Princess Julapon Science High School Chang. I am Pariyakon Pachunpai.
I am Gulapat Sontimuyang.
I am Pranchok Titrawut.
The presentation aims to introduce our project, the study of water quality changes in Chang Canal from 2023 to 2026, and present the result of our research. River and freshwater resources are important for human use and ecosystem. However, they are increasingly affected by pollution and environment changes, leading to declining water quality and biodiversity. Chang in Trang Province is an important water source for local communities, but recently, changes such as higher turbidity and reduced aquatic organisms such as possible water quality problems. This study aims to assess water quality in Chang by measuring temperature, dissolved oxygen, pH, electrical conductivity, and turbidity for sustainable water management.
Our research questions are 1. How do changes in water quality over the past 4 years reflect the trends of environmental factors? 2. Is there any difference in water quality parameters based on physical and chemical characteristics?
Our project is aiming to first, to study the change in water quality over a period of 4 years in study area. Second, to compare the physical and chemical water quality parameters of each water source. Last, to analyze the trends of change in water quality that reflects environment factor in study area.
Our predictions of the projects. 1. Changes in water quality over the past 4 years reflections in environmental factor in the study. 2. The physical and chemical water quality parameters of each water source are different.
Study was conducted at Chang, Trang Province, Thailand. This area is a freshwater canal influenced by surrounding human activity and natural factors. We are conducted information on 28 January 2025. On to our materials. This is mainly of water quality testing. 1. Conductivity meter. 2. pH meter. 3. diometer. 4. Laser meter. 5. Salinity tester. 6. Turbidity tube. 7. Thermometer.
First, we select our conducting point. We have chosen 5 different connecting points for conducting water sampling. Next, we do a field testing, measure water temperature by using a thermometer. We use turbidity tube for turbidity. We use laser meter for surface water temperature. We use pH sensor for the pH. We use DO sensor for the DO. And last, we use EC meter for conductivity. Next, we analyze our data.
The first graph shows changes in water temperatures from 2023 to 2026 compared with the standard value. Overall, water temperature shows slight fluctuations but remains close to the standard range. In 2023, the average temperature was about 29.4 degrees Celsius, which was slightly lower than the standard. The highest temperature was recorded in 2024 as approximately 32 degrees Celsius. In contrast, 2025 and 2026 show temperature from about 30.82 degrees Celsius and 30.12 degrees Celsius, which were closer to the standard value. This indicates that water temperature remains relatively stable over time. The second graph presents changes in water surface temperatures. The results show greater variations compared to water temperature in 2025. Surface temperatures reached the highest value at approximately 35.28 degrees Celsius, indicating strong heat accumulations during that period. In contrast, 2023 and 2026 show value closer to the standard, suggesting more stable surface conditions.
The third graph shows changes in pH value from 2023 to 2026. Overall, the pH remained close to the neutral with only slight variation. In 2023, the pH was slightly higher than the standard, while in 2024 and 2025 it decreased around the neutral. The highest pH value were recorded in 2026, indicating slightly more alkaline condition. However, all the values were still in an acceptable range, showing that the water quality remained generally safe. The fourth graph illustrates turbidity changes from 2023 to 2026. Overall, turbidity values were lower than the standard in all the years, indicating relatively clear water conditions. The lowest turbidity was recorded in 2023, while the highest value occurred in 2026. However, the changes remained with acceptable range, suggesting the water quality was generally stable.
The fifth graph shows change in dissolved oxygen level. Dissolved oxygen gradually decreased from 5.73 mg per liter in 2023 to 4.52 mg per liter in 2026. This decreasing trend may be related to higher temperature, increased organic matter, and reduced oxygen solubility in water, which can affect aquatic life. The sixth graph shows change in electrical conductivity from 2023 to 2026. Overall, conductivity increased gradually but remained below the standard volume. The lowest volume was recorded in 2023, while the highest was in 2026. This trend suggests a gradual increase in dissolved substance in the water over time.
The seventh graph shows changes in salinity from 2023 to 2026. Overall, salinity sizes increased over time and was mostly higher than the standard. The highest value occurred in 2025, while 2024 was closest to the standard. This trend suggests a gradual increase in salinity, possible influenced by environmental factors such as evaporations or seawater intrusions.
Conclusion: water quality in Chang showed noticeable changes from 2023 to 2026. The study revealed increasing turbidity and conductivity along with decreasing dissolving oxygen level. These changes indicate a gradual decline in water quality and potential risks to the freshwater ecosystem. If these conditions continue without proper management, they may negatively affect water use in aquatic life in the future. Therefore, continuous water quality monitoring, pollution control, and increased public awareness are essential for sustainable management for Chang.
Results of water quality study in Chang, Prof, Thailand from 2023 to 2026. There were clear changes in both physical and chemical water parameters. The study showed that turbidity, electrical conductivity, and salinity gradually increased, while dissolved oxygen level decreased. This change indicates a decline in water quality and may affect the balance of the freshwater ecosystem in this area.
Overall, the results indicate clear changes in both physical and chemical water quality parameters. Turbidity, electrical conductivity, and salinity show increasing trends, while dissolved oxygen decreased over time. These changes are influenced by climate conditions, seasonal rainfall, surface runoff, and human activities around the canal. Previous studies have reported that during rainy season, increased runoff and sediments inputs can raise turbidity level, while during the dry season, higher temperature can increase salinity and conductivity. These findings are consistent with our study.
Higher water temperature also reduces the ability of water to hold dissolved oxygen, combined with organic matter input. This leads to increased oxygen consumption by microorganisms, resulting in lower dissolved oxygen level. And these are our reference. Thank you.